Hi everyone. Today topic is compounding. Compounding means it is a process. It will compressing the data and then expanding. That means it is minimizing and maximizing the data by using different conversions. Compounding is a process of compressing and then expanding. With compounding system, the higher amplitude analog signals are compressed. With compounding system, the higher amplitude analog signals are compressed prior to prior to transmission and then expanding amplitude more than on lower amplitude signals in the receiver. That means the overall meaning of compounding, it will compressing the data and then expanding the data. So compounding is mainly classified two types: analog compounding and digital compounding. Analog compounding, digital compounding and analog compounding, two types of compoundings. This is the one of the type of compounding, digital compounding. In digital compounding, compression at the transmit end after the input samples have been converted in a linear PCM code and expressions at the receiver end prior to PCM encoding. That means the compressing data will be transmitted to the end of the samples have been converted linear PCM codes. That means analog samples are converted is in the form of linear PCM codes, and then after it will compressed is in the form of digital. So this is the one of the type of compounding. Next one is analog compounding. Analog compounding is implemented using a special designed diodes inserted in the analog signals path in the PCM transmitter prior to sample and hold circuits, and this method is currently being used to closely approximate a logarithmic function and are often called log PCM codes. So it is a second method of compounding. Implemented using a special design diodes inserted in the analog signal path in the PCM transmitter prior to the sample and hold circuit. Analog compounding is classified two types: A-law and mu-law. These are the two types of families of compounding. Compounding is classified two types: digital and analog. And again analog compounding is classified two types: A-law and mu-law. This is the one of the type of mu-law. One commonly used compounding function is called mu-law compounding, defined as V out equal to V maximum into log of 1 plus mu of V in by V maximum log of 1 plus mu. It is a formula to calculate how much of data will be compressed or how much of data will be expanded by using mu-law. Here voltage indicates V and mu equals to the rate of change of signals. PCM telephone systems using or mu law compounding are mainly used in US, Canada and Japan. US, Canada and Japan. Here we are seeing mu equal to 225. What is the meaning of mu equal to 225? Just we are seeing the diagram. Here it is a diagram of mu law compounding. It is a diagram of mu law compounding. Here mu equal to 0. If mu equal to 0, there is no compression. That means data will not compressed. When I am increasing the value of mu, if mu equal to 5, some data will be compressed or decreased. In the graph we are clearly seeing mu equal to 0, there is no compression, and mu equal to 25, some data will be compressed. Up to mu equal to increased to 25, the data will be compressed a lot. That's why US, Canada and Japan are used the maximum value of 225, which will the maximum limit to compress the data. So that's why we are using mu law compounding. That's why we are using mu law compounding. So these are the graphical representation of mu law compounding. Below normalized input and above normalized output. Simple meaning, when we are increasing mu, then automatically the compression will be increased. When we are decreasing mu value, then automatically mu value will be decreased. The same phenomenon is also applying A law. European countries practically A law compounding are used. In previous, mu law compounding are used US, Canada and Japan. But in A law compounding use European countries like Italy, England, some European countries, islands. These are all some European countries are used compounding. A law compression in continuous domain PDF is the function of x equal to sin of x by 1 plus log of a, where a dot of x, a mod of x 0 less than or equal 1 plus L of a mod of x 1 by a less than. These are the conditions. When we are changing the a value, then automatically the compressing data will be decreasing or increasing. Where here x is the input signal, sin of x is the sin of the input signal, that x is the absolute value of x. Here we are already previously discussed. These are two standard compounding methods. Mu law is used in North America and Japan and Canada, and A law is used European countries. If mu value is increased, mu equal to 1, mu equal to 0 1 5 mu equal to 100 mu equal to 225, the data will be compressed. In the same manner, a equal to 1, there is no some data will be compressed. A equal to more data will be compressed up to a equal to 18.76 or 8 a equal to 100. So the both ALA and MULA will be represents when we are changing the values of A and mu, then automatically the data will be compressed. When we are increasing mu value or A value, the data will be increased. When we are decreasing mu and A values, then automatically the data will be expanded. So that's why now we are see the meaning. Companding is the process of compression and then expanding. Compression and then expanding. Here it is clearly observed when we are using ALA and MULA, we can easily change the data will be compressed and then expanding. The overall diagram we are also seeing, it is the fundamental block diagram of compounding. For example, in this input side, the analog signal will be entering to the band pass filter. The analog signal will be entering to the band pass filter. Both upper and lower side we are using band pass filters, analog compressor, analog expander, sample and hold circuit, analog to digital converter, digital to analog converter, parallel to serial converter, serial to parallel converter. That means reverse operation of below and upper blocks. So for example, when we are entering analog signals from band pass filter, it will providing additional frequency to balancing the signals or either compressing or expanding the signals, and then it will be passing through the analog compressor. Already we know when we are using mu and ALAs, when we are increasing A and mu values, then automatically the data will be compressed. And see the below analog expander, when we are decreasing A and mu values, then automatically the data will be expanded. So that is the major roles of analog expander and analog compressor. Next, sample and hold circuits. Sample and hold circuits, already in previous classes we know sample and hold circuit. A continuous time signal will be converted is in the form of discrete signals to the equal intervals, and then after that will be converted to the digital signals or pulse amplitude modulation, PAM, pulse amplitude modulation. From the above diagram we are also seeing the pulse PAM signal. It will indicate zeros and ones. That means it will convert the signals is in the form of digital. And then after we are using analog to digital converter or digital to analog converter or serial to parallel converter, parallel to serial converter, we can easily convert the shape of the signals and transmit the signals from the output side. So here already we know serial to parallel converter, parallel to serial converter, analog to digital and digital to analog. The only one major block is analog compressor and analog expander. These are the two major blocks in compounding system. By using analog compressor and analog expander, we can applying the values from the notations of mu and A. When we are increasing mu values and A values, then automatically data will be increased. When we are decreasing the mu and A values, then automatically data will be expanded. So that is the brief history of compounding. Compounding single meaning is compression and then expanding. Compression and then expanding. Next class we are seeing the block diagram of differential pulse code modulation and advantages. Thank you very much.